Hello, here in Chapter 4, we introduce the idea of probability. Probability on its own is a very rich and interesting topic. Here we will explore some of the basic concepts, and later on, it'll be helpful when we want to, for instance, test a particular assumption about a population. So, what is a probability? We think of a probability as a numerical measure of the likelihood that a particular event will occur. In statistics, we collect data from a sample to try and understand or infer something about a population. So here we would use sample data to help us infer something about a population. In probability, we're given some information about a population and we would like to know something about our sample. For instance, how likely is it that that sample would occur by chance? And probabilities really help us understand this idea better. So we're given something about a population and we want to know how likely is a particular sample. So let's look at some terminology. An event is any collection of results or outcomes of a procedure. A simple event is an outcome that cannot be broken down further into simpler components. And a sample space are all the possible outcomes for a particular event. And so a sample space will be a collection of simple events. So let's think about a specific example to help us understand these ideas. Let's take the example of flipping a coin. So when we're flipping a coin, there are two possible outcomes, a heads or a tails. So here we can imagine our sample space would be these two possible outcomes, heads or tails. And in this case, these are simple outcomes, simple events that cannot be broken down further. And here we have all the possible events in this instance for flipping a coin. So this would be our sample space. Say, for instance, we are rolling a six-sided die. In this case, our die would have the possibility of landing on one of its six sides every time we roll it. Okay, so your sample space would consist of those six possible outcomes. It could either land on a 1, a 2, a 3, 4, a 5, or a 6. And each of these events here, are rolling a 1 or 2 or 3 and so on, those could not be broken down further into simpler events. So in this case, right, this is our sample space consisting of all the possible simple events that could occur when rolling a six-sided die. So to see an event that is perhaps not a simple event, well, let's consider the event A of, say, rolling a number greater than 4. In this case, A, the event A, would consist of several simple outcomes. For instance, A could be broken down further into the events of rolling a 5 or rolling a 6. In either case, you're getting a number that's greater than 4. So you get a 5 or a 6 would be the possible simple events that would occur in the event A. Now let's look at an example here. Suppose we're rolling a six-sided fair die, and here fair we're assuming to mean that every side of that die has an equally likely possibility of landing on one of those six sides. And so here again, let's write our sample space. We saw this earlier. It's one of those six sides that it could possibly land on here. So sample space consists of those six possible outcomes. And here we're asking, what is the probability that when I roll this die, it lands on the number 5? And so that's going to be just one of my possible outcomes here. This 5 could be one of these 6 possible outcomes. Since each of these 6 outcomes is equally likely, we have a 1/6 probability of that occurring. So let's think about this other example where we have the event of rolling an even number. So the probability of rolling an even number. Well, now we look at our sample space. I see there are actually 3 outcomes, a 2, a 4, or a 6, that would be in that event of rolling an even number. And so the probability of rolling an even number would be 3/6, because we have each of these 3 outcomes is equally likely. And so we have a 3/6 probability of that occurring.